Welcome to Lab Life with the Air Force Research Laboratory.
Hi, I'm Michelle.
And I'm Kenneth.
Today we talk to AFRL senior historian Kevin Resnick about aliens' tweets in the beginning of Air Force engineering.
In 3, 2, 1.
We're here today with Kevin Resnick. He's the senior historian here at AFRL. Thank you for joining us today.
My pleasure. I'm always happy to talk about the history of the labs and airplanes.
We're excited to cut into it, but we want to start off. We heard that you're the person to talk to about the air quotes alien.
I get asked about aliens a lot. The easy answer is we have no aliens. We have no alien spacecraft. We've been tied into that story since probably the 1950s. The way the story goes is everybody's heard of Roswell, right? The aliens crashed out there in 1947. Mysterious Air Force men loaded up alien bodies in an alien spacecraft and put it on a train and set it to Wright-Patterson Air Force Base, which was brand new by then. It had been combined from Wright Field and Patterson Field. And the thought was that here we had not only the laboratories that study and develop technology, we also had what was the Air Technical Intelligence Group that had taken German technology and Japanese technology from World War II, crashed airplanes, crashed V-1 missiles and V-2 rockets, that kind of thing, and kind of reversed engineered them, figure out where the weak spots are and stuff. So it was only natural that if you had extraterrestrial technology, you'd send it to these same experts, right? And then, so we've been hiding alien bodies here or spacecraft in the infamous Hangar 18 for 70 years. So whenever somebody hears that I work at Wright-Patterson Air Force Base, the aliens always come up and, okay, what about Hangar 18 and all this? If you look at a map of the base, there is no Hangar 18, so maybe it's a stealth hangar or something. You can't find it. I don't know. In 16 years, I've never found it. But the short answer to your question, there are no aliens, there are no alien spacecraft, but it's kind of a fun little story, and it's always a good thing to talk about at a cocktail party over a martini or a glass of wine, right?
Yeah, no, it's a good way to start a conversation. So speaking on that same note then, like Hangar 18 and aliens, what are some other historical rumors you may have heard, especially about Wright-Patterson, or at least the Air Force, that you've had to clear up in the past?
One of my retired colleagues and I had this conversation not that long ago. We were trying to think of other things that have had this sort of staying power like the aliens, and there really isn't too much. The rumors that you hear or the stories that we have to correct are usually involving things that we invented or we didn't invent, or somebody outside the labs invented, but really we did. And we'll touch on this a little bit later, I think. So it's a lot of that kind of thing. It's like, hey, I heard Wright-Pat was involved in this, or why didn't you guys do this? And well, in fact, we weren't involved in that, or in fact, we originated this. So it's really more that sort of technical correction rather than these lingering rumors. I guess other interesting bits that may have caused issues outside the labs is, of course, we had German scientists come here after World War II, the Project Paperclip, where the guys who went to work for NASA, Werner von Braun and his rocket group, are the most famous, of course, but there were a group that came to work for the Air Force here at Wright Field, among other places, to work on programs that would help us in the Cold War against the Soviets. And they made some substantial contributions. Many were here for years. Many more left to go to contractors or went back to Germany or wherever. So they helped contribute in various ways. But the local population was kind of mixed in their response to this. So there were a lot of issues at the time. Hey, are these guys helping us? Are they not helping us? What are they really doing here? There's that kind of thing. But that's probably not something that persists very much to this day, of course, because that's a long time ago. But that's the only other one of that magnitude that I can think of offhand.
Sure. So when you're at the cocktail parties talking about these rumors and aliens and things, when you get to actually describing your job to these people or your friends or your family, what do you tell them you do as an Air Force historian?
The first reaction I get is, wait, the Air Force has historians? That's interesting. And then the second reaction I get is either A, wow, I hated history in high school, or B, wow, I love history, and how can I do that job, right? The fact is the Air Force has, we actually over 100 historians, close to 200 in what they call the Air Force History Museums program. Every unit of a particular size, basically at the wing level or above, or a center like AFRL or the Life Cycle Management Center, for instance, has a historian. And the Air Force has required these really since World War II. Once the Air Force was going to be kind of an independent organization, they really saw history as something valuable to to their leadership. And Hap Arnold, who of course is a major figure in AFRL, right, in pushing science and technology, he was also a big supporter of having a group of historians documenting what's going on so that the leadership could understand why we were where we were and where we were going. So the field has grown and contracted over the decades, of course. And as I said, now we've got a pretty sizable cadre. And here at AFRL, there are a few of us that cover the labs. But historians are just a part of that pie. We also have museum specialists, curators, archivists. There's a whole group of people that are involved in doing this job. And the historians are the ones who are sitting down doing the writing, of course, and a lot of research. But we're helped in our jobs by all these other people. And they help not only history, but what we call heritage, what has our organization done, hey, how do we feel good about our organization? Let's look at these great accomplishments that we've done. What are the key leaders, our key personnel, what are these great things that we've accomplished? That falls into this category we call heritage. So we do some of that, and I guess social media to a degree falls under that as well. Let's get the story of our unit out there. Whereas history is, we think of it as more analytical. Let's figure out why, not just the what, but the why. Why are we doing these things? Why are we here? Those kind of bigger issues. So we do some of both. So how does that translate to a day-to-day job, right? Well, for instance, today here I am talking to you fine people, of course. But this morning I was looking through documents going back to World War I, looking at aircraft investigations. We'll talk about that in a little bit, I think, about McCook Field, but also about some of our current hypersonic research. Just shows the breadth of what we have to cover as historians here at AFRL over the 102-year history that we've had. And so it's a lot of research, and I probably spend 75 to 80% of my time doing research, whether that is in an archives looking through boxes for documents, whether that's digitally looking for documents on databases, or like everybody else hitting Google and finding different things, or going through what we might have in our own archives and finding documentation for whatever project I'm currently working on. Or research can count as I'm going to go out and interview this rocket scientist, or this material scientist, or this technician, or this technology director, something like that, about whatever it is I'm working on. And then the writing ends up actually being a pretty small part of what we do. That's kind of the tip of the iceberg. That's what the people see. And it could be something interesting like these recent books we put out, these aiming higher volumes, or it could be work for our leadership that they need 2 to 5 page papers on what are some of the AFRL's greatest hits, or hey, the Secretary of the Air Force is interested in a particular technology. Can you provide some examples of historical efforts for that? So we do a lot of those kind of things that our research feeds into.
And some days you get to witness history too. Like recently I ran into you we had some astronauts coming in testing in our centrifuge. So it's pretty cool.
That's honestly the best part of my job, is actually seeing the work we do. It's sitting in my office, can be pretty boring as it is for anybody. But if I get to go out and witness an engine test, or witness runs on a centrifuge, or whatever it might be, that's the great stuff. You see history in the making. I'd love to go see some flight tests and things like that. Back when we were testing a pulse detonation engine probably 10 or 12 years ago, got to see that run out here on the runway by the museum, which was pretty cool. You get to go see these things happening, and as a historian to witness these events just gives you kind of a unique perspective on what's happening there, and you can talk to the people that are involved right there in real time. Hey, what's going on here? If you're a historian of, the Middle Ages or antiquity, you don't get to witness these kind of things, and they may think, well, hey, you're doing history as it happens. Well, that's really more journalism or something. No, it's a different brand of history, but it has this different kind of level of excitement, and a little presentism that, you don't get the perspective of 100 years or 1,000 years of reflection, but you do actually get to be there while it's happening and kind of document what's going on in a very, very real way. So.
That's awesome. Yeah, I was going to say, I'm kind of touching on something you mentioned before then. So you mentioned a lot, almost 80% of your day's research. Do you have any examples of, let's say, a really difficult piece of information, or how far you've had to go to get some pieces to fill out a document?
Yeah, and anything old is hard for us to find. We were talking a little bit before this, but I'll reiterate that the early documentation for the Air Force, and you'd probably see this in the Army or Navy as well, has been scattered to the wind in a lot of ways. You'll find, if you're talking about McCook Field, our progenitor, 100 years ago, The documents for that some might be located at the National Archives in Washington. Some might be at the National Archives in, different facilities. We might have some here at the Air Force Museum. We might have some in our own collection. So it can be a frustrating process trying to pin down any particular item that you're looking for, especially since the older material isn't well cataloged. And what you might find is that, hey, you're interested in McCook Field? Okay, we've got 100 boxes on that, and the finding aid might give you 4 or 5 categories, but then you're still talking 25 boxes per category, and that's a lot of stuff to go through. And if you're trying to find information on one particular airplane or one particular individual, you can be really frustrated. But I've had great luck with archivists all around the country helping me out. I let them know what I'm working on, and they'll pull bits of information. People get excited about historians like me using their collections, and they'll really go to great lengths to help out and find these things if they have them. It's just a matter of finding out where they are in the first place. And unfortunately, our budget, since we do work for the government, isn't huge, so we don't get to do a lot of travel to go out to these places and spend weeks or months at an archives like you might if you're under an academic grant of some sort where all you're doing is that research. We have our day jobs for the Air Force, of course, and so we don't have that luxury necessarily, but we try to get people to help us remotely as much as we can.
So you've touched on some of the cool stuff you've done as a historian in your day-to-day. How did you get interested in aviation history, or what path took you to sit here with us today?
It's usually somebody's kid is interested in history, right? My high school student wants to be a historian, and I'm afraid they're going to be unemployed, right? Or they're going to be working fast food for the rest of their life. What do you do, with a history degree? And they're like, hey, you work as a historian. That's great. Can you tell me, how this happens? And I think of myself in a way like a unicorn. I'm one of the few people that actually managed to do history in the field that they're interested in, and at a place they want to be doing it. It doesn't happen that often. So to start from the beginning, I grew up in this area around Dayton. I can trace my interest in aviation. Really, space was my big thing. To seeing Star Wars in the movie theater when I was 4 years old. I waited in line to see Star Wars there with my parents and my grandparents. Like I said, I was 4 years old, and it just blew my mind. I'm like, wow, that's what I want to do. I want to fly in space. Everything else is out the window. That's what I'm going to do with my life, right? And so, from that point on, I was interested in anything to do with Air Force and NASA. I would go to the air shows here. My walls were papered with pictures of airplanes like, the ones we work on now. And to me, that's a great thing because my office walls have the pictures of the same airplanes that I had on my walls as a kid, but now I'm like the historian responsible for writing about these things, right? So it just blows my mind that I was able to kind of connect these dots, without having known it at the time. But I kept up that interest for, as long as I can remember, but I'd wanted to be an engineer and thought that I would be able to work for, the Air Force or the space program or something like that. But turns out I was a relatively mediocre engineer. So if I'd stuck with that line of work, I probably would have been designing, springs for, some obscure machine in some, obscure industry. And that didn't really hold a lot of excitement for me. But I was really interested in technology and still really interested in airplanes. And when I was an undergraduate student at the University of Dayton, the chairperson there did the history of science and technology, and he introduced me to this field. So when I was looking at changing my majors, he's like, well, you should consider this as a tech guy. There's this whole field of stuff, and that just blew my mind that, hey, this field exists. I'd never heard of it. So it's like, sure, let me do that. And so from that point on, I was going to do history of technology. And so I looked at graduate programs that did that and ended up at Georgia Tech. They had at the time, one of the few programs in the country that really specialized in the history of technology. And I went down there and did my graduate work and just had really fortuitous timing that when I was in graduate school, the NASA Johnson Space Center in Houston put out a call for interns to come work. They were reinvigorating their history program. And so they were bringing in graduate students or maybe late undergrads to work for a summer as an intern there. And of course, everybody knew of my interest in space, so I got an email. This was way before, social media or a lot of internet presence. This was in the mid-'90s. I got emails from several different people saying, hey, you'd be perfect for this. And I thought, wow, I would be perfect for this. Let me go do that. And so I was lucky enough to get selected for that program. And I spent 2 or 3 summers as a summer intern at the Johnson Space Center. And what they were doing was, as part of invigorating their history program, was they were starting up an oral history project. They had realized that the people who had worked on the Mercury, Gemini, and Apollo programs were getting older, and a lot of them were starting to die off, and nobody had recorded their stories. Of course, astronauts had been interviewed, out the wazoo, right? Everybody's seen astronaut interviews, so there wasn't a whole lot more value gained by talking to those guys. But what about all the flight controllers that sat at the mission control consoles, the guys who sat in the back room of the mission control consoles, or the guys who sat in buildings across the way that worked for the engineering and development directorates? What about these guys? Nobody had ever talked to a lot of them. The guys that were doing things very similar to what we do at AFRL, but doing that for the space program. The guys that manage the manned spacecraft. All these great technologies, all these great stories, and guys that nobody had ever bothered to interview. So that was really our thing. So we did a lot of research and writing on these people, similar to what I do now. And then we would sit down and interview these guys, sometimes for hours, talking about what they did. And we just ended up with this tremendous treasure trove of information about the early space program, and that program's gone on. It's still going on, actually, and I think they've done their 1000th interview relatively recently. So it's just a huge breadth. Yeah, they've been interviewing people all over the country that were involved with the space program, and other ones for NASA headquarters and so forth. So a lot of different things. So they ended up picking me up after, I think it was my 3rd summer, to work there full time. And so I went there to work, and I stayed there for another 3 or 4 years until this opportunity came up to work for AFRL. The one drawback of working at NASA Johnson, which was like my dream job again as a kid, really interested in the space program. I couldn't have thought of a better place to be. I mean, I got to talk to astronauts. I got to, we'll walk through the parking lot, and there goes John Glenn the other way. It's that kind of stuff. It was super cool, but we were all contractors. We were on a year-to-year basis, basically, as at the pleasure of the center director. If they had money that year, great, we're all employed. If they decided money was tight, then you might all the contract might get canceled, and then you're a historian looking for a job somewhere, which is tough. But again, fortuitous timing, a job here opened up here at AFRL, and it was a civil service position. And for me, it was coming back home. As I said, I'd grown up in the area, and I was very familiar with the labs. When in high school, I'd actually visited out here a couple of times as part of what they called an explorer program. And so, I knew a lot of the cool stuff they had done. Of course, I'd been to the museum a million times and all that. So it's like, well, I have this opportunity to get a permanent career and, still doing research and development engineering, which is really what I love to do, the history of not just aerospace, but particularly, research and development, science and technology and all of that. So it was something I couldn't pass up. And my boss thought I was a great fit for it. So I came out here and the summer of 2002, and I've been here ever since. So yeah, over 16 years now.
Back to the birthplace of aviation, which kind of leads me to a little transition here. So you have a Twitter persona at McCook Field, and McCook Field is a big spot in aviation history in Dayton, part of our history here. Could you touch on McCook Field and what you're doing with that Twitter handle?
So military aviation, particularly in the U.S. Army, was not much of a thing prior to World War I. We had a training facility out at North Island in California, where we had one engineer out there who was basically trying to keep everybody from crashing their airplanes all the time. I think the fatality rate for Army flyers out there prior to adding an engineer was something like 50%. It was terrible,
wow.
Yeah.
Oh, wow.
The airplanes were just, you're talking barely past the Wright brothers, 1909 military flyer. I mean, you had other models going, but it was terribly unreliable. So we brought in an engineer, the first man, as far as we know, to receive an aeronautical engineering degree in the U.S., Grover Loaning, was hired out there to fix things up. And so he really, under his watch, he basically eliminated that fatality rate to 0. He did a great job, but you're talking a very small facility and one person. Once World War I hits, the United States finds itself very far behind the rest of the world. For one thing, Europe had been in World War I since 1914, and we didn't get involved until April of 1917. So we were already lagging behind by almost 3 years in terms of developing material for war. our Air Force as it was practically non-existent. When World War I broke out, we had, depending on how you make the count, about 60 airplanes, and that's it. Almost all of those were training airplanes, some light scout type things, but nothing combat worthy. I mean, zero. If you look at the stats from 1914, American government investment in aeronautical research was something like 8th in the world, behind countries like Mexico. It was practically non-existent. There was no organization, there was nothing. The planes we did have were supporting the cavalry. Let's do some scouting, and then everything else was devoted to training for that particular mission. We had no fighting planes at all. So when we got involved in World War I, Congress says, well, we need an Air Force. So they throw $640 million at us to build up an Air Force. But the problem is we didn't know how to do that, and we didn't know how to do it quickly. So they did what they thought was best, which let's take the best European designs from our allies. We went to Italy, to France, to England, picked the best designs, recommended the ones we build here, and then, okay, we'll take those designs, we'll build up an American industry and crank out thousands of airplanes. We projected we would have something like 10,000 planes within a year, wildly optimistic estimates. But the idea was, let's not do a lot of development, let's copy what we have. Well, it turns out to be a lot more difficult than you think, because for one thing, they over there use the metric system, we over here use the English system. So even something like a screw, we don't have the machines to make metric thread screws here. So I mean, just very basic stuff. And so if every measurement is in millimeters or meters or kilograms, we have to convert everything. And then of course you end up with odd fractions or decimals. It doesn't work very well. So you start fudging these things, then you end up with an airplane that's very different from what it was originally intended. And it also turns out that airplanes, at least at that time, didn't really lend themselves that well to American methods of mass production. You think Henry Ford and the assembly line, and that was still relatively new at that time. Because airplanes were made out of cloth and wood, it was more like cabinet making or something even fancier, like making a piano. There's so many intricate moving parts with wood and cloth and paint, and metal pieces that have to work together intricately. You can't just throw that on an assembly line at the time, and there's a lot of craft involved there, and we just weren't set up for that. No American airplane manufacturers could do that. And car manufacturers, of course, weren't building cars the same way, so it was they had huge growing pains. And we quickly figured out that we need some kind of technical organization to handle all of this, to be kind of the central clearinghouse for deciding what we need to do, what we need to fix, how we can adapt these planes, how we can improve them and make them work. That's the genesis of McCook Field. So we started an engineering organization first in Washington, D.C. Basically two guys. One does engine design. This is Jesse Vincent. And then one was airplane design, a gentleman by the name of Virginius Clark. So the two of them are kind of the foundation. And then they decide, well, a two-man office in Washington, D.C. is not going to cut it. We need a place where we actually have laboratories and shops and a landing strip. We need to go somewhere. So originally they were going to put their facility at Langley Field in Virginia, and because Langley was under construction as an air base at the time. But it turns out that it took too long to actually construct these facilities. They were looking at kind of more permanent structures and so forth. So like, well, where can we build a temporary facility, quickly be up and running within a couple of months? Well, one of the heads of aircraft production was a man, Colonel Edward Deeds. He was a local Dayton guy who had been involved with the National Cash Register Corporation, NCR, very familiar with manufacturing, and of course a big Dayton booster. And he said, hey, well, we've got some facilities in Dayton that might suit the bill. If we're just looking for something now, we'll make the arrangements. Later let's get something there. So Jesse Vincent comes out here to Dayton and looks at a facility in what's now Moraine, south of Dayton. They're like, okay, well, let's do this. It was actually Colonel Deeds' personal facility right next to a factory he was putting together to build one of these European design airplanes. And they're like, hey, this suits us great, let's have it. Deeds says, well, maybe not that one. Don't take that one, because we're using that for this factory and we're going to make a lot of money building airplanes for the war, right? But he's like, I've got this other facility just north of downtown that we started to build a private airstrip there, and we were going to use it for an air school, but right now there's basically nothing there. So you guys can have that. Not an ideal location. It was, as I said, just north of downtown, kind of in a bend of the river. It had been completely flooded in the Great Flood of Dayton, 1912. But hey, this is only going to be there for a little while anyway, so we'll just throw up some temporary buildings. We'll pave the runway, and there we go. okay, we'll go with that. So they picked that site, and then they built up McCook Field. I think they picked it, if I'm remembering correctly, in September, and then Jesse Vincent gets here in October of 1917, and by December they're fully up and running. They built their hangars, they built their initial shops, they're getting test facilities put in there, and they're good to go. They name it McCook Field because that area of land had been owned previously by the McCook family, the so-called Fighting McCooks of Civil War fame. There were, I think, 6 of them that had been involved in the Civil War. There was a general involved, and so they were kind of a famous family. And as I said, they owned part of that land previously, so they just thought, hey, let's just name it after them. And it was, at one point, it was the only field in the Air Service that hadn't been named for a flyer who had died in the course of them in Langley, of course, that hadn't been named for a flyer that had died in an airplane crash. So they build up this facility thinking it's going to be temporary. They take charge of all the engineering. The technical activities go on there, but they actually have a couple of different buildings in downtown Dayton where they do all the administrative stuff. They move 3 different buildings in the course of like 9 months. They keep going. Every time there's a new building put up, they move to it. But the Bureau of Aircraft Production goes there. Later organization called the Division of Military Aeronautics goes there. So they're running these kind of 2 separate facilities. And then out here at What's Wright-Patterson Air Force Base, there was another facility that they called it Wilbur Wright Field that was doing training for aviators. There was a depot there for material, and there was an ordnance, or an armorer school, I'm sorry, that was there. So we had separate facilities around town. Because McCook Field was doing the technical activities, we really view that as kind of the initial facility that later becomes the Air Force Research Laboratory. They were the ones doing the same kind of activities that we do now. And you see a lot of that same technical stuff. They were working on materials. They were working on propulsion. Well, some areas not so much. We're not doing a whole lot of cloth and rubber research right now. For instance, we're not doing much in the way of propellers. They were doing those things then, of course, but a lot of the same things. So that's really kind of where our origins came from. And for me, you'd mentioned the McCook Field Twitter handle. I had, in the course of researching for a book we were putting out, I'd come across the diary for Jesse Vincent, his wartime diary, where he picks up in January of 1918 and then cuts off, I think, in November of 1918. He covers most of that year, and he gives a day-by-day activity list of his activities, or at least the significant ones, of what's going on. So it was a really great overview of, what it was like to be here. Leaves big pieces out, mind you, like anybody might in their diary, because he saw this as kind of an official accounting rather than his, bedside kind of, here are my thoughts on the day. It was, hey, I went here and there and did this and that, that kind of thing. But I thought, with Twitter being what it is, this is kind of a perfect medium to have this and tell this piece of the Air Force story that people don't really know, right? If you, outside of our small community or anybody who's interested in early aviation, most people haven't heard of McCook Field. So let's get this out there and maybe generate a little bit of enthusiasm. So I just started tweeting under his persona as Jesse Vincent. It's like, let's do a little bit of introduction, and this is a great time to throw some pictures out there, show all this cool stuff that they were doing. And unfortunately for me, Jesse, once he had been an engineer for the Packard Corporation, he was actually the vice president of engineering before the war. Then he was brought in to design the Liberty aircraft engine, which was our standard engine that we tried to use for all our airplanes during World War I. And it ended up being our greatest contribution to it, but it caused a lot of issues at the time. But then once the war ended, he was quick to go back to business. He wanted to go back to making money. He left, and then Thurman Bain, who's the current subject of McCook Field, the current author of it, he did not leave his diary for me, so conveniently, unfortunately, but I'm still picking up where I can using newspaper articles and things like that, where I know the dates and trying to fill in as much information about what's going on 100 years ago on this date kind of activity. So it's just a fun thing to do to document our early years, and it helps with my research for later projects that involve that time period. So.
I found it really fascinating. For me, that space, that McCook Field, now they call it Kettering Field, and it's a place where you play softball or kickball. Right. So it's amazing what started there and what's grown to become the Air Force Research Laboratory in several different iterations and forms. So.
Yeah, kind of bouncing off that idea then, so in terms of working on Twitter, especially being a historian now using it, how do you see social media as a good place for discourse for historians? Because it's very quick, how you can ask questions, even fact check, things like that.
Yeah, Twitter is a very good way to find out what you don't know or what you are mistaken about. 'Cause if you tweet something and there's a some small error in there, people are quick to correct you, which is good and bad, right? As a historian, you want to get your facts straight, but as you say, that develops a great discourse among people. Because one thing I always I tell my son a lot is, it's important to know what you don't know. And I know that I'm not the expert in everything. AFRL, we've got 9 different directorates scattered all over the country and facilities all over the world. There's no way as a historian I can know 100 years of all of this stuff. So, there are certainly areas I specialize in, but I know that there are always people out there that know more than I do about any particular activity, and I'm always happy to leverage their expertise. If I'm trying to write about a World War I airplane, there are whole communities devoted to World War I aviation. Hey, I need to know about a particular gun site on a particular airplane, I can find the history of that particular gun site that somebody's written at some point because they're really into that. And that's wonderful. I mean, I love that. And Twitter's great for finding those people that you may otherwise not come across without trying to dig through a bunch of old journals that may or may not be online, right? You may have to dig through journals that, at the library and spend hours and hours, versus if you tweet something, hey, does anybody know about X, Y, and Z? And then, you'll find an expert pretty quickly about any of this stuff. And so it's a great way to find out about what you don't know and to bounce ideas off of people and to get engaged with experts in other areas that you may not have thought of to get different perspectives on things. And in fact, I engage with a lot of other Air Force historians on there from other bases, the Air Force Academy and so forth, that really help me out, and it provides new venues for getting my ideas out there. There are people that do podcasts or do sort of these e-journal kind of things that you can get something out there relatively quickly if you want to write a short article or provide some analysis that it may take you years or months to get out in any kind of print journal. So I really appreciate those opportunities and the community that exists there.
Yeah, your field is definitely evolving, how you capture history and record it.
Yeah, and now you have, again, that running history that you wrote out for McCook Field, especially with Jesse Vincent, which has been awesome. So, and actually, one other question about that I meant to ask was, in terms of Jesse Vincent, what would you say is one of the most, I guess, interesting or fun facts about him you wouldn't realize unless you had read through his journal like you did?
He was an interesting character that, I've done some research on what happened to him after the war and so forth, because he's essentially the head of engineering for the Air Service during this time period, but he had never trained as an engineer. He had just some sort of innate mechanical acumen. I mean, he had grown up on a farm, partly in Illinois, partly in Missouri, but then he had shown this mechanical aptitude, and so he worked for like the Burroughs Adding Machine Company and had become part of their invention department, and then he worked for Hudson Motor Car, and then moved to Packard in 1912, as I recall, and then just moved up the chain relatively quickly, but he had never gone to college. He had taken, by some reports, some correspondence engineering courses, which I guess was not really all that atypical at the time, but he didn't have that sort of formal training. And so for him to be overseeing the Air Service engineering was really, and certainly in the eyes of some of his critics, was a bit of a stretch. Because he certainly proved his mettle as an engine designer, and that's really what his big thing at Packard had been. He had been working on engines there and had designed one of the first 12-cylinder motors for cars. And he had applied that expertise to designing the Liberty engine and so forth. But if you read the investigations of aircraft production that happened after the war, based mainly on the fact that we didn't produce as many airplanes as we said, so where did all this money go? There was a lot of criticism from some areas about why did we have all these automobile guys working in airplanes when airplanes and automobiles are very different. And so they took a blunt of that criticism. And Jesse, of course, was not immune to that, but one of the criticisms was, well, we have these automobile guys who don't know anything about airplanes, haven't been trained on airplanes, running the show, and that was what really caused a problem. I'm not sure I agree with that interpretation necessarily, but that was the contemporary issue there. So reading through Jesse's stuff, you think, he really knows what he's talking about, but it was all basically self-taught.
That's
which is pretty impressive, yeah.
Especially when he was a fledgling field, you got to think he was a DIY aeronautic engineer. So
yeah. Well, in a way, Thurman Bain wasn't that much different. His successor, he had gone to West Point, so of course he had a degree, but he learned aeronautics by correspondence from reading articles that had been put out by the engineering department at MIT that appeared in Aviation, which is now Aviation Week in space technology. He read the articles that they'd put out. A guy, Alexander Clement, who actually came to work here at McCook Field during the war, he studied those, and then so he was put in charge of designing an aeronautical engineering curriculum at North Island after he had just been a student there himself. There was a lot of self-teaching going on because there just weren't departments set up for this at the time. I mean, they were starting to be a little bit, but otherwise not very much. So there was a lot of autodidacts in the program.
So Kevin, one final question while we have you. It comes from one of our followers on Twitter, Michael Heil. He asked, what are the most significant inventions and technological advancements to come out of the Air Force Research Laboratory and its predecessor labs? Now, I think that question could probably be a podcast series on its own, but if you could pick one invention or technological advancement to highlight to us.
Who invented what is a tricky question. The research lab, while we do in-house research, we're really kind of the center of a technological community. We, even ever since the McCook Field days, and it was set up this way on purpose, serve as a technical clearinghouse of knowledge. We serve as a catalyst for invention. In addition to making our own inventions, we take ideas from other places, we develop them, we foster them, we provide money to do that. We may generate our own ideas and provide funding to companies to develop those because we may not have the in-house capabilities to do that. So when you say invention, it's not like, the classic image of Thomas Edison, he invents the light bulb on his own, which of course didn't happen, but there's that sort of model. So I just want to put that out there that AFRL is involved in a lot of these inventions. We probably should get much greater credit for many of these things than we actually do. So there are certainly ones where I think we're really central to the development of that. If we hadn't been involved, they might have taken years to appear or may not have appeared at all. The one example that comes to mind is fly-by-wire. This is something that we initially had a lot of resistance to, but let me explain the technology first. Traditional airplanes are controlled with, you've got your control stick and your rudder pedals that were connected, again, ever since the Wright brothers days by cables and pulleys to your flight control surfaces, your ailerons, your rudder, your elevators. So when you pull a stick a certain way, the flight control surfaces move to make you turn. Pretty simple, right? But when airplane speeds get faster and faster, when you're talking hundreds of miles an hour instead of tens of miles an hour, the force going across those flight control surfaces is so strong that you don't have enough muscle power to make them move. So you need to start providing some boost to that. So that's when we introduce hydraulics into the system. So now you're having kind of an artificial component. Well, fly-by-wire is taking that a step beyond even providing an automatic pilot where you've got gyroscopes controlling, the flight control surface instead of just the pilot, where you've got beyond what they call stability augmentation, like, hey, let's keep the aircraft relatively stable if there are bumps from turbulence or something like that. So fly-by-wire is the idea of what happens if we replace these cables with electrical wires. And that's really the first idea of it. It's pretty basic. Let's get rid of wires. We're going to have an electronic input on one end, and then we're going to have the electric motor on the other end moving the hydraulic actuator. And so just in between, we're going to have an electrical cable saying that's where the signal is going to go. Much less vulnerable than hydraulics that can get holes in them if you get shot at, right? And then once they leak, you can't control your airplane. But if you can run one wire around the top of the airplane, one on the bottom of the airplane, one on the left or right, you get a lot of redundancy, a lot more survivability. Important in a combat plane. But that's also why you don't see a lot of interest in this from the commercial world, for instance. They're not getting shot at, right? So they don't really care about their survivability. They're not going Mach 2 in a DC-3 or in a 707, something like that. So this is one of these technologies that's particular to the military at first. There's not really a lot of visibility or interest from the commercial world. So AFRL, what was then at the time the aircraft laboratory, and then which becomes the flight dynamics laboratory, is really the center of this. These guys in flight control there do an experiment. They take a B-47 bomber that they happen to have sitting around, and they're like, okay, well, we're going to try this. We're going to replace these mechanical controls with electrical controls and see what happens. So they do it in the pitch axis. That's the nose up and down, and it actually works pretty well. They use the first, what you want to think of as a flight control computer. So they had gone beyond just the step of putting a wire in there, but we're going to actually have a device in there that a computer that when you move the control stick, the computer is going to output a signal to the wire and tell the, in this case, the elevators what to do. It's an analog computer, meaning everything's kind of hardwired in there. There's no software. But that's really the first practical demonstration of fly-by-wire. And so we build on that. We have a program called the Survivable Flight Control System where they do this with an F4 where it's going to be controllable in all 3 axes, pitch, yaw, and roll. That's all going to be done by fly-by-wire, again with an analog computer. At the same time, NASA's working on a fly-by-wire system based on the Apollo spacecraft controls, except they see that the Air Force is doing analog, so they're going to do a digital computer. It's what you think of now where everything is run by software, and you can change the software easier to tell it what to do. It's not as reliable at the time. We're talking the early 1970s, but it's a lot more flexible. So NASA's interested in that. We, being the Air Force, are of course interested in let's go with reliable. We want survivable. We want consistency. And so these two efforts kind of proceed in parallel. But again, without the military's interest there, we wouldn't have seen it. And then the first application of it is to the F-16, gets this reputation as the electric jet because it's the first fly-by-wire airplane. But then since then, you see that applied to not just military airplanes, but also to commercial airplanes because it provides greater level of control and precision, particularly when you're talking about computerized flight controls where everything needs to be done as efficiently as possible. Fly-by-wire makes all of that possible. Plus, it tends to be a lot lighter, a lot less maintenance intensive than having a bunch of hydraulics on board your aircraft. So that's just one of the ones I'm interested in that I think really highlights the critical role of the military in developing this broader technology.
We've learned a lot today, haven't we, Ken?
Seriously, yeah. I appreciate it. Thank you for coming down.
You're welcome. It's always a pleasure. I'm happy to come back.
Yeah, we hope to have you back. Thanks, Kevin.
Thanks, guys.
Follow us on Facebook, Twitter, Instagram, LinkedIn, and YouTube at AF Research Lab. And remember, stay curious.
Logging off.